Atkin, pursuing her degree in the Department of Soil and Crop Sciences, has always been fascinated by space exploration. She decided to take on the challenge of growing crops on the Moon, where the conditions are very different from Earth. The Moon has no soil, only dust, she explained. The dust is very fine and has no organic matter, nutrients, or microbes that plants need. It also has harmful elements like iron and aluminum that can damage plant cells. And, of course, there is less gravity, more radiation, and extreme temperatures. Atkin developed a special soil amendment to overcome these obstacles and improve the lunar dust's quality and fertility. She worked with Sara Oliveira Santos, a doctoral student at Brown University, who helped her solve the water retention and drainage issues of the dust. The secret ingredients: fungi and worms. Atkin's soil amendment consists of two main components: beneficial fungi and vermicompost. The fungi, which form a symbiotic relationship with the plant roots, help protect the plants from the toxic elements in the dust. They also enhance the plant's ability to absorb water and nutrients. The vermicompost, the product of worm digestion, provides organic matter and nutrients to the dust. Atkin said that worms could be brought to the Moon and fed with the astronauts' biowaste, such as food scraps, clothing, and hygiene items. Atkin chose chickpeas as her crop because they are legumes that can benefit from the fungi. They are also protein-rich and use less water and nitrogen than other crops. Atkin and her team managed to grow chickpeas to seed in up to 75% lunar dust simulant, a mixture that mimics the composition of the real moon dust. This is the first time anyone has done this, and it has huge implications for the future of space exploration. Atkin said her research could enable astronauts to grow their food on the Moon, reducing their dependence on prepackaged supplies. This would save costs and resources and improve the astronauts' health and morale. However, she also acknowledged some limitations and challenges. For instance, the chickpeas took longer to mature on the moon dust than on Earth, showing signs of stress. She said that she will continue to study the effects of multiple generations of plants and the possibility of growing other crops. The novelty about using vermiculture is that it can all be done in space, whether in a space station or on the Moon, reducing the need for resupply missions, she said. This study was published in a preprint paper posted on bArchive. Food sustainability is one of the most significant barriers to long-term space travel. Providing resources from Earth is not cost-efficient, and resupply missions are not viable to meet the needs of long-term life in deep space conditions. Plants in space can provide a source of nutrition and oxygen, reducing the reliance on packaged foods, reducing resupply needs, and extending the duration of missions. Using lunar regolith simulant, we employ a novel methodology to create a sustainable and productive growth medium to support the cultivation of horticultural crops on the Moon. Implementing microbial soil regeneration mechanisms derived from Earth, we leverage the interaction between arbuscular mycorrhizal fungi, AMF, and vermicompost, VC, to create a fertile LRS matrix. These amendments can sequester toxic contaminants, improve soil structure, and increase plant stress tolerance. We demonstrate the ability to produce chickpea, Cichia arietinum, in lunar regolith simulant augmented with AMF and VC under climate-controlled conditions. We cultivated chickpea to seed in a mixture containing 75% lunar regolith simulant. Preliminary results suggest that higher LRS contents induce heightened stress responses. However, plants grown in 100% LRS inoculated with arbuscular mycorrhizal fungi demonstrated an average 2-week survival extension compared to non-inoculated plants. This study provides, for the first time, a baseline for chickpea germination in varying mixtures of LRS and VC and will inform future studies as humanity goes back to the Moon.